My name is Michael Minella. I work for VMware as one of the members of the Spring team. I'm co-project lead for SpringBatch, founder of Spring Cloud Task, worked on the JSR for enterprise batch processing, speaker, author, curmudgeon at large, blah, blah, blah. 2 bits of self-promotion. One is I'm on a podcast. We actually recorded an episode here last night called Offheap. You can check it out on the web, javaoffheap.com, or anywhere fine podcasts are found. It's a bunch of guys basically talking about the current ecosystem of Java in general. I also have a book out, so if any of this is interesting to you at all, please check out my book. It came out last year. Quick lay of the land. So who here is comfortable with Spring? Good. SpringBatch. Okay. Spring integration. The hands are falling, yep. ETL processing in general. Okay. Stream processing. And functions. Lambda, that kind of thing. Okay. So what are we going to talk about today? So I've been the lead or co-lead of SpringBatch now it'll be 8 years in September, so 7.5 years. And over that time, I've had a lot of conversations with people. I've talked to them at conferences, I've talked to them on Stack Overflow, I've talked to them on Gitter, clients, all different avenues. But a lot of my conversations end up being the same. I came to having the same 2 or 3 or 4 things that I drill into every single time. And a couple of those examples are, when all you have is a hammer, everything looks like a nail. So people that are comfortable with one piece of Spring and try and solve everything with that one piece of Spring they're comfortable with. You also have resume-driven development, right? You've got people that are like, but that's the hot thing. I want to do the hot thing, even though it may not be the right thing for what they're looking for. And so my goal today is to have those conversations with all of you. So my goal today is really to make sure that all of you have, when it comes down to choosing an architecture for your applications, that you have the right tool in your toolbox for the job. That make sense? I want this to be an interactive presentation, obviously, as much as time allows. I'll be here for later if anybody wants. But don't be shy, ask questions when you have them. So we're going to talk about a quick SpringBatch 101. A little less than half of the hands went up when I asked who knows SpringBatch. So I want to make sure we level set everybody on what is SpringBatch, how does it work, that kind of thing. You're not going to become a SpringBatch expert in the dozen or so slides I cover it in, but it should at least allow you to be comfortable with some of the lingo I'm going to throw around later. Then we'll look at a use case of when I think we should use batch processing, as well as one when I think we shouldn't use batch processing. Cool? All right, so SpringBatch 101. What is batch processing? It helps to get a definition of this stuff, right? So batch processing is defined as the code my boss wrote before I was born and now I'm stuck maintaining. Not quite. All joking aside, so everybody throw out some ideas on what would you include in a definition around batch processing? Sorry, louder. Working on a collection of objects? Okay, there's something over here. Bulk, yep, okay. Anything else? Non-interactive, yep. Scheduled, okay. Don't know who specifically said it, but okay. Anything else? So the way I define batch processing is it's the processing of a finite amount of data, so you have a batch of something, without interaction or interruption. When you think about batch processing, the big thing that separates it from every other workload out there is, to your point, it's non-interactive. Whether you're doing integration-based applications, whether you're doing web applications, just about every other workload out there you can think of, how do you deploy it? You build an application, you put it on a server or run it as Microservice or whatever deployment topology you choose, and then it sits and waits for something to happen. And then when something happens, whether that be a web request, whether it be a message over messaging queue, something, then it does some processing and then sends a response or sends something down the line, and then it waits again. Whereas batch processing is different. Batch processing, you gather up all your information up at the beginning, and then you say, go. And it churns through that, processes all that, and then shuts down. That's the big difference between batch processing and those other workloads. Let's walk through some lingo that's related to batch processing. So first of all, a job. So when we talk about that flow, the entire thing that I'm going to run from start to finish, that's going to be a job. A job can be made up of multiple steps. So each step is an independent unit of processing that I can run either sequentially, in parallel, etc. There are two main different kinds of steps within SpringBatch. There are other ones, but for today, I'm going to keep it simple. There are two main ones, which is a tasklet and a chunk-based step. A tasklet step is a step that has, there's an interface called tasklet. There's a method called execute on it. That execute method, basically, we're going to run whatever code you stick in there within a transaction. We can run it for you once. We can run it for you in a loop for 100 times. It's completely up to you. Chunk-based processing is really what used to be item-based processing. So here you're looping over some type of data. So I've got a file with 1,000 records in it. I've got a million database records I need to go over. That kind of thing. And those are broken up into chunks so that we can process them iteratively. An item is what makes up a chunk. So this is where there's a bit of a science and a bit of art to choosing what is the item within your batch job. So when you think about processing bank transactions, right? You could have the customer be the item. You could have the bank account be the item. You could have a transaction be the item. It all depends on what level you're processing your stuff at. But what fundamentally within SpringBatch, that's going to be the thing you're looping over in a chunk-based step. And a chunk is a collection of items. So these items are collected and processed within a single transaction. So the idea being that if you have a step that needs to process a million database records, you probably don't want to process all 1 million database records in a single transaction, right? It's probably at a minimum impractical, and there are a whole other reasons why you wouldn't want to do that. So we divide that into chunks. So let's say we want to have a chunk size of 100 or some dynamic thing. It's up to you. So every 100 items, we read, process, and write those within a transaction and commit the transaction. Then we do the next 100, and the next 100, and the next 100. That allows us to do all kinds of robust error handling, like start, or stop, retry, skip, restart, all those kinds of things. If we look at the flow of a step, 3 chunk-based steps, this is a 3-step job. So step 1, step 2, step 3. The way this works is step 1 is going to start, process, then finish. Then step 2 is going to start, process, then finish. Then step 3 is going to start, process, then finish. Now, obviously, there's plenty of optimizations you can do with the SpringBatch. If 2 and 3 are completely unrelated, you can run them in parallel and get all kinds of crazy stuff going on. But from a hello world level stuff, that's how that works. Each one of these chunk-based items have up to 3 usual components. I say up to 3 because the middle one is optional. So you've got an item reader, which provides the input to the step. The item processor does any actual processing. And the item writer generates the output. The processor obviously being optional. Excuse me. All right, I'll turn off the mic when I do that next time. Sorry. So this is the sequence diagram for a chunk-based step. So the step's going to call the item reader until a chunk, the volume of data that we need to process within a chunk has been gathered. So if we're reading 100 records, it's going to call the read method on the item reader 100 times. Get all those records within a list. Then it's going to loop over those items one at a time with the item processor. So calling the item processor one at a time for each one of the items. Again, there's plenty of optimizations. I don't want to get into any of that right now. And the last thing is once all of the items have been processed, you can take the entire list and pass that as a single chunk to the item writer. Well, why is the writer different from the other ones? Because the writer on the right side, we can actually do some optimizations from an I/O perspective that you really can't do effectively in the process and read perspective. So like flushing a bunch of bytes out to a disk at once, or a batch update in a database, or those kinds of things. The architecture of SpringBatch. So we've talked about job steps, reader, processor, writer. Batch processing is inherently stateful. So you have a start, you have an end, you keep track of state as the processing goes on, so you can do error handling like restarting, skipping, and all that kinds of stuff. And so how these components integrate in a stateful way comes down to the job repository. The job repository is a relational database that keeps track of the state of all these different components. So the job launcher is going to report to the job repository, hey, I started job 1. The job is going to report to the job repository, hey, I started step 1 or step 2. The step is going to report to the job repository, hey, I started, or I did this chunk or that chunk, or I read this many items, or I wrote that many items, I skipped this many items, and so forth. The job repository is required if you want restart and those kinds of things. If you don't care though, you can use an in-memory database and just basically ignore that. Does that make sense? Let's go ahead and write a quick batch job to see what that looks like. So we're going to go to Josh Long's favorite place on the internet, or second favorite, because productions is first. Second one is start.spring.io. That's all fine, don't care. And then we want to grab some batch stuff. We want to grab some JDBC, and let's just use H2 so we don't have to worry about the rest. Next. That's not the right spot though. Looks good. Yeah, great. New, I'm going to do a new, where are we at? No. Even. Why are you not picking this up as a Maven project? There we go. Yeah, that's better. Go ahead and kill that. And we're also going to go ahead and kill the test. Don't tell anybody. Okay, so I've got a batch application here. If you've seen Spring Boot, most of this should be familiar to you. So I've got enable boot application. That's the normal Spring Boot annotation. I've got a main method at the bottom. Again, should be pretty useful or pretty comfortable. This enable batch processing. So I talked about the job repository and the job launcher and those pieces, right? So this enable batch processing is going to bootstrap all those into your application context for you. So I don't have to define all those other beans for you. It also is going to include a couple builders that I'll use. So in this case, I've got a job builder factory and a step builder factory. Job builder factory is going to give me a factory that I can use to build my jobs. The step builder factory is going to give me a builder that I can use to build a step. Make sense? Cool. Let's go ahead and build our job. That's how to define a job with SpringBatch to start. So this is a single step job. So this .job builder factory.get, that's gonna get me a builder to build my job. Start is what step or flow I want to start with. And then if I were to make this a multi-step thing, I could do .next, and pass steps, and there's all kinds of transitions and stuff we could get into. Again, not what we're looking to get through for this part of the talk, so I'm gonna keep it simple for this. And then for the step, I'm going to do a tasklet step. Okay, so this is going to be a tasklet-based step. All it's going to do is a system.out.println, basically saying that I ran that. And then it's going to return repeat status.finished. Remember I said when I was talking about the tasklet-based step, you can run that once or you can have SpringBatch run it 100 times in a loop. It's up to you. The way you control whether or not to run it again is by that repeat status. So if I did .continuable, it would run it again until finished was passed. Make sense? Let's go ahead and run it. So you can see the batch job was run with no parameters. I didn't pass anything on the command line. It executed step 1. Obviously, it said hello. And then the step was completed and the job was completed as well. Pretty straightforward, right? Questions about any of the SpringBatch 101 type stuff before I continue on? Cool. That's so cute. We just wrote a program like it was 1971. But this is 2020. We have all kinds of new things, like Spring Integration wasn't around back then, and Kafka is the silver bullet for everything, and Lambda is going to take over the world, and we got all these cool toys, right? I want to play with those. And with all those, how do I migrate off a batch? How do I get rid of all this batch processing? The TLDR of it is you probably don't. And I want to be clear, I'm not going to spend the rest of the time bashing these other technologies or anything like that. That's not my goal here. With any solution, you can build a solution with any stack you want, right? You could build a web server with COBOL. You could do ETL with Spring Integration. It's all possible. When you're choosing an architecture, it's really about managing trade-offs. So maximizing the positives while minimizing the negatives. And so there are 3 main questions when I start to evaluate, is SpringBatch the right option for this solution that I ask. First one is, what is your data? So is it a finite amount of data? In other words, do you have a batch of something? Or is it something that is a never-ending stream? Like you don't know when it's going to end. The second one I ask is, what is the process type? Is this a process that actually has a defined life cycle with a start and end? Or is this intended just to process a never-ending stream of data? And the last one I ask is, what happens when things go wrong? So typically when things go wrong, what we'll see in a few minutes, things can get interesting depending on what stack you choose. Let's focus in on a specific use case. And I kept this really simple. We're going to import some CSV files into a database. Like I said, really complicated stuff. Now you may think, if you are familiar with batch processing or ETL processing, that this is a no-brainer batch application. I see people nodding. But people are still writing articles about doing data integration with files. And it's not like this is an old article. This was written 2 months ago. So people are still doing this kind of processing with technologies that are questionable. I mean, I don't think that I would recommend to most people to do data integration with files as a modern way of architecting a system. And so we're going to focus on this import process piece. That's that box right there. We're going to look at 3 different ways of implementing it. The first one is a monolithic application with Spring Integration inside. So I've got some code here we can take a look at. So go ahead and kill that. So this is just your normal Spring Boot application. I'll skip over that. The input file we're going to be processing, let me grab that really quick. So it's got 334 lines in it. Each one says the word 1, the word 2, and then the number 3. Word 4, word 5, number 6, and so forth down to 1,000. So that's what we're going to be processing. Like I said, real tough stuff. So first way we're going to do this is with a single monolithic Spring Integration application. So I've got an application that's got a configuration here. I'm going to build an integration flow. So if you're familiar with Spring Integration, this is basically how you define the flow of processing. So Spring Integration, for those who have never used it, is basically the Spring implementation of the Enterprise Integration Patterns book. So if you were to go and grab that book, I forget who the publisher is. It's a black book. And basically take those and sit down with Spring and implement those patterns. That's what Spring Integration is. And so here what we're going to do is we've got a flow from a source of some kind. So it's actually a file source. So we're going to look at the file source is going to grab a file. Then I've got to split the file. So if I don't split the file, it's going to pass the whole file as a handle by itself. We want the individual records. So I'm going to use this file splitter to identify, to break up the file into rows. I'm going to transform them from a single string into into a map, I believe. No, into an object. I'm going to transform basically that one string into an object. So I'll parse that CSV into 3 fields. And then I'm going to insert that into a database. Make sense? And then how this works, the Spring integration pieces we use are the JDBC message handler. So this is every message that comes in. I'm going to query that message and write a JDBC query. So in this case, insert into foo values, the sequence number of the record, so basically a count, and then the fields from the POJO. That's the write. And on the read side, the file reading message source factory bean, and I'm just passing in where to look for the file to write or read from. Make sense? Let me go ahead and run it. Okay, so full disclosure, you can see the last 2 commands I did were delete and recreate the database, so nothing on my sleeve. Use SpringBatch. And we have all the records in there, 334 as we expect, right? That's the rosy scenario, right? Let's go ahead and delete those. And so now, again, that's the rosy scenario, right? What happens when things go wrong? So let's go ahead and go into our input file, and let's go ahead and grab something, let's say here, and I'm going to throw a Z on the end. Obviously, that's not a valid integer, right? So go ahead and save that and rerun the job, or rerun our process. Okay, something broke. Number format exception, yep, that's what we would expect, right? But now what state were we left in? So we got 423 records in there. So we got that one. I still have the rest of them to do. If I restart this as is, what will happen? Be confident in your answers so I can actually hear you. Duplicates, exactly, yeah. It'll start back at the beginning. So that's a problem, right? And now obviously you can get into writing all kinds of Spring integration code to handle skips and retries and all that kind of stuff. But I want to bring up Spring integration's own documentation. As observed, or as described in the overview at the very beginning of this manual, one of the main motivations behind a message-oriented framework, such as Spring integration, is to promote loose coupling between components. It does a good job of that, right? However, the advantages also have some drawbacks. Some things become more complicated in a loosely coupled environment, and one example is error handling. That's a perfect example. This is a perfect example of that. So now I'm responsible for writing the code to decide, do I want to skip this? Do I want to retry it? Do I, on a restart, how does this work? All that is now mine as a developer's responsibility. Does that make sense? So probably not the ideal solution for this kind of use case. Clean that up. So now let's take a look at the next option, which is Microservice with Spring Cloud Stream and Spring Cloud Function. Here we have 2 applications that are out of the box that Spring just provides for you, the file source and the database sync. Those I'm going to be using just out of the box, the way they come. And then I wrote a transformer that basically does the same thing as the transformer in mine. We'll look at that code in just a second. So here we've got I'll be using, actually, back up. So the way this works is these are 3 independent applications. These are 3 independent microservices. there's rabbit in between each one. So the file source will read the file, split the file into lines, and then send a message for each line over rabbit to the transformer. The transformer will pick it up, do its thing, and send a message out to the database sync. The database sync will pick it up off of a different topic and write it out to the database. So basically the same flow, just in a distributed environment with persistent messaging middleware in the middle. That make sense? So if we take a look at my my processor, all these basically work the same way. Like I said, 2 of them are out of the box. I wrote a third one. So here I've got a Spring Boot application. Again, nothing fancy here. And then using Spring Cloud Function, I can define just a Java util function that will do some work based on what I get in. And that will return what gets wrapped in a message and goes down the line. So here I've got the data coming in, like I said, is just the string. Share whatever you're watching on Netflix. The input to this is a single string that's the line within the file. The output is the mapping to, in this case I'm using a map, string. So what I'm going to do is I'm going to go ahead and run each of these 3 applications. I already have Rabbit running, so Rabbit's running locally. So I'm going to go ahead and get these guys up and running. I did delete, right? Yeah. So I'm going to start these in reverse order so that everybody's ready to pick up the messages as they come through. So start the JDBC sync first. So I specify the jar file to run. Again, all these are just boot applications. I specify the jar to run, the table name to update. So in this case, we're updating foo. The columns that I want to update. So these are just a mapping of column name, colon, and then a spell expression on how to get the value from the message. So in this case, it's headers, that's their header sequence number, and then first :1, second :2, third :3. Then I need to pass in, well, obviously database driver, data source, all the data source configuration, and then Spring Cloud Stream bindings input destination. That's the name of the topic that I'll be picking messages up off of. So this is my sync. It'll have one that's input. My function will have an input and an output, and my source will have one that's just an output. So I'm going to start that up. While we're waiting for those, I can do those. All right, so that guy's running, that guy's running. So this one will actually pick up the file. Oops. If I don't, that finger. There's a bunch of stuff going across the wire. Everything got in, as we'd expect, right? So again, that looked good. What happens when things go wrong? Go and delete, and I'm going to fix my file, change my file again. So add my Z, and then the nice thing about this architecture is you can just kill the source and restart the source, and everything just works. So when I restart the source, it'll pick up the file again because I don't have that as persistent. That's all there. Let's see what state we were left in. Basically the same way we were with Spring integration, although now we've got a distributed environment. So now I got to trace down logs across not just one app, but 3. I need to figure out where my messages went. Are they sitting in a queue somewhere? Do I need to clean up queues as well as the database? Again, same problems as the monolithic Spring integration aspect, just now I've got more complexity in a distributed environment. Does that make sense? So let's go ahead and take a look at this. using, as I'm sure will come as no surprise, SpringBatch. Oops. Actually, no. So last option here is SpringBatch. So here we've got the same file, same input and output. I'm going to replace the configuration in Spring Integration with the configuration of SpringBatch. Oops. So I've got a batch application, same main method. This is all the same stuff that we saw in the when I did the SpringBatch 101 stuff. So this jobbuilder.get, start, set build. Now in step one, this is a chunk-based step. So here I've got a reader and a writer. So the reader is this flat file item reader. The writer is a JDBC batch item writer. These are two components out of SpringBatch, so all I need to do is tell it what to do. And then you can see I'm reading a POJO in from the reader and passing it on as a POJO to the writer. So I've set my chunk size to 10, so every 10 items, it'll do that loop we saw in the sequence diagram as well as commit. And then you got the reader and the writer. So the reader, flat file item reader builder, get name. So this, if you need a name if you have more than one of these readers in the same step, so we can, for restartability purposes. What's the file I'm going to read? It's a delimited file, so SpringBatch has facilities to manage that. Names, I just specify basically the name of each column in my CSV, so 1, 2, 3. And then SpringBatch, by specifying the target type, will call set1, set2, and set3 on the POJO as it reads them in. So I don't need to write any code to do the mapping. Similar on the writing side, so we've got the JDBC batch item writer. I specify a data source. It's being mapped, meaning I can use a spell expression here to get the values that I care about. So in this case, insert into foo into values item count. So SpringBatch will provide the item count for you if you code it correctly. And then 1, 2, and 3. So it'll call get 1, get 2, and get 3. Does that make sense? Let's go ahead and run this. Good. There's one other important thing to realize in this one. On the Spring integration applications and the Spring Cloud Stream ones, I had to stop the processes. So if I was running this, let's say, in a cloud environment, right? I'm responsible for shutting down the instances if they're not being used. Here, it just shuts down, using SpringBatch, it just shuts down for me. So I don't have to worry about that. And most cloud platforms have some type of task primitive that allows you to run something to completion, allowing you to run this kind of workload natively on that platform without having to worry about keeping things up or that kind of thing. Kubernetes got jobs, Cloud Foundry's got tasks, et cetera. But so we can see here, the job was launched, execute step 1, it ran, completed. And if we go over to MySQL, everything got in there fine. Now let's go ahead and do the same thing again. I'm going to drop the database, create it. We'll do this again. This time I'm going to add in my bad parameter, or my bad value. So we should expect this to fail, right? Just like it has up to now. Go and run it. And there it failed, as expected. And you can see, yeah, there was one error, type mismatch, just like we would expect. Let's look what was left in our database. Oops. It goes up to 420. What happened to all those records? Right. The transaction was rolled back to the last good state. So now, if we just delete that and run it again, Everything completed as expected. And now, 234. No dupes, no worries, no nothing. Does that make sense? Questions? Cool. So is that was that. So which process should we use? Should we use batch processing or something else for that use case? Batch, yeah. Let's talk about another use case. Don't worry, I don't have code for this one. It'll go a lot quicker, I promise. So this one is a different use case. This is actually, you've got a web application that's ingesting a click stream. So you got, every time somebody clicks something, you're recording that interaction, right? So you've got a click service, it's persistent to Kafka, and somebody's doing some analytics on it down the line. Again, probably something everybody's at least talked about. Look at this again from the same 3 viewpoints. You could do this with a monolithic application with Spring integration. You'd have basically clickstream the application. It accepts in, let's say via HTTP. You basically have 2 flows in here. One would be HTTP to Kafka, essentially, and then another one, reading off of Kafka, doing some type of analytics, and doing something with that. Nothing horrible with that design. It would work. The big things there would be testability and scaling, right? So testability. If I make a change to one of those flows, I need to validate that all the other flows work the way I expect them to, right? In order to get that into production. And also scaling, if I want to scale this option, I've got to scale the world, right? So there's no way for me to say, well, the analytics is a slow piece, let me just scale that piece. So I've got to scale everything or nothing. Microservices approach is another option. So here we'd have a clicks service that ingests stuff. So again, think HTTP to Kafka, and then an analytics service that does something else. Here, it's probably a better option. You've got the opportunity to scale each one of these independently. So let's say you've got high traffic, but the analytics, you're not worried about performance. So you scale a click stream, or let's say the analytics service is running behind. You can scale those independently. You can test and deploy them independently, all those kinds of things. The last option would be doing this via batch. So you could do this via batch. You could probably, the click service could, let's say, write this to a file and then ingest that. You could have the click services write to Kafka, and then SpringBatch actually has a reader and writer for Kafka. You could, do the analysis service as a batch application if you wanted. But going back to the 3 questions, this is streaming data, right? There's no batch of data that we're looking to process. So because of that, it really doesn't fit into a batch style application. So batch or not to batch, don't batch this one. Like I said, there are many ways to solve all these problems, right? I could go through tons of different use cases. Obviously, there's plenty of different ways to handle any one of these use cases with whatever stack you want. The goal is really about minimizing those trade-offs. And when you think about a new architecture, like I said, think about what are the types of data you're processing? Is it a finite amount of data that you're processing? Does it make sense to have a short-lived process, especially in the cloud world these days? You don't want to be paying for processing time you're not using. So if you can have an application that starts up, does a batch, and shuts back down, there are real financial benefits to that. And then finally, what happens when things go wrong? So is the trade-off of latency and other things that you get with those streaming and integration style workloads worth the extra maintenance on your plate for writing the error handling code and whatnot? That's all I got. Questions? Yeah. Excellent question. So the question was, how did SpringBatch not to duplicate records? So, so I said SpringBatch is stateful, right? So the reader that I use, the flat file item reader, keeps track of how many rows it's read. And when basically every commit, it stores that value in the database. When things restart, it says, hey, this is a restart. Where were we last time? Reestablishes that count, and then continues from there. And even on non-transactional items, it's not perfect, but even there we'll do best effort. So a good example is writing to a file. So if you're writing to a file, obviously it's not a transactional resource. You can't roll back what you did, but we do keep track of how many bytes were written as of the last good commit, and we will truncate the file to that point and continue on from there. So even some things like email, there's an email writer. We can't call back email. But some of those things we do a best effort. There's other, yeah. So the question was, how would you handle incoming files at random times? And so that's actually a really good question because SpringBatch does not handle orchestration. So when and how it's launched is not up to SpringBatch. There's a whole nother talk I've got on that kind of thing. There's a number of different ways to do it. Actually, it's common to see it using both SpringBatch and Spring integration together, where you'd have a file puller looking at a folder. When a file gets dropped, it sends basically the message, hey, you got a file, this is where it's at, pick it up, and then the batch job will launch and kick that off. That's a very common use case in general. There are other ways to handle it if you wanted, but yeah. Yeah. Yep. So how would you handle a hierarchical file? Let's say an XML file that's a little more complex, or a JSON file that's a little more complex. Yeah. So we've got. Right. Yep. 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 Yeah. And so there's two pieces to that. Number one is using the right reader or writer. I was using the simple one because I didn't want to dwell on get too bogged down in the domain and that kind of thing for everybody to understand that. We have XML readers and writers. We've got JSON readers and writers that handle all kinds of marshalling and all that kind of stuff, and basically anything you want as far as that goes. What else was I going to say? I had 2 points and I forgot the other one. Yeah.
What is your recommendation on running a scheduled job? I want this job to get executed at a defined interval versus some other time I want to run
Yep.
some other event.
Yep. So yeah, that's a very common use case, right? So SpringBatch can be done that way. Whether it be via data flow on a platform using the platform scheduler. You can use something like Control M or those types of schedulers. Those are all options. It's an enterprise schedule tool. So SpringBatch doesn't handle orchestration, like I said, and it's been my experience that orchestration tools for batch processing, especially if you're going like from mainframe to this kind of stuff, is a very religious topic. People are like, thou shalt not touch my scheduler. And so because that's one of the main reasons we don't do orchestration, we want to integrate with whatever you've got. So you could do cron if you want, all the way up to paying millions of dollars for an enterprise scheduler. It's up to you. Yeah.
You mentioned that it's going to have the reference for the number of lines that loaded for the previous campaign transaction or whatever. What's the unique identifier for the name or is
So that's a good question. So the question was, what is the unique identifier for the file itself? And that is, it's the name of the file. Yeah. So the restart functionality assumes that the data set it's looking at from start run to 2 is the same. There's nothing within SpringBatch that's going to validate that that's true. So if you were to, like a good example is, let's say you've got a database and you're processing 1 million records that are date stamped, right? And you process it and it fails halfway through, and 3 more records come in somewhere else that are still within that date range that you're processing. SpringBatch is going to do nothing to figure out whether or not those belong or not. It's on you to determine that with other facilities. Yeah. Okay.
So in the hierarchical file, so there is a record probably in different tables.
Mm-hmm.
So when it tries to fetch back the last correct file, then tries to load that.
Yeah, so it's all within a single transaction, right? So it's all, that goes back to that was the other point I was going to make was there's a bit of an art to deciding what an item is. And that's really where that comes down to is an item the child on that hierarchy? Is it the parent? Where does that boundary make sense based on what you're processing? And what makes sense to roll back, what doesn't, all that kind of stuff. In the back.
So I have a real use case that I'm having problem with. I have two files, one with 11 million records, the other one with 8 million records. I gotta basically compare the records.
Yep.
And merge them if they are the same.
Yep.
In the processor.
Okay.
Currently, I'm using multi-resource aggregator.
Yep.
I've been not being successfully.
Yep, that's not going to work. That's not what you're describing. That's not going to work. That's because it's going to read one after the other.
Correct. It's not doing the right things. What would you recommend?
Let's take that offline. That's very specific to your world. Yeah. So the question was, how does the job repository manage? It's up to you. We provide no, SpringBatch itself provides no cleanup or anything like that. So yeah, it is going to infinitely grow. Spring Cloud Dataflow recently, I think in 2.0, added facilities to clear out that stuff if you're interested. Because it really depends on your requirements and auditability and all that kind of stuff. So it's really up to you to define that. Anything else? Thanks, everybody.